Okay, we need a root of this x cubed minus x minus 2. We are given a starting guess 1.5 and a tolerance and a limit and maximum iteration which are allowed. So we will easily just get a quick derivative 3x squared minus 1 and then just put in all the values over here. And just like that, we get all our result on our screen. But the thing is, this Newton method is not built-in function, and we are not just given by default. You have to install it in our Ti-nspire. Okay, so now you have to first download the Newton script from this GitHub link that I've added in the description, and then you just press the download raw file, and then after that's downloaded, you also have to download the student software. There's one, if you have like a Mac, then you have to use this link, otherwise XE link for Windows. And after that is done, now connect your calculator to your PC using the USB cable, the same one you're using for charging the calculator. And now inside the student software, open document toolbox and then content explorer and then your downloaded file on your PC, and then we go to the, after that we just drag and drop the Newton file inside the mylib folder on calculator, since I already have it, so I will just replace it, and just like that it's installed on your calculator. And make sure you don't place it anywhere else, only in the mylib folder, right? Okay, so now you have two ways to actually use this method. First is to directly go to my library and then go to Newton file and then go to run, and over here you can easily get the answer. But a much better way, or the more recommended method, is to instead make a new document, and over here first you will have to refresh the libraries and make a new shortcut, a library shortcut with the name of the file and what you will call it, right? And then you can directly use it from here, right? It is much better to use it this way, because it lets you combine multiple computational methods in a single document, right? So from the same GitHub repo, like there's like a bisection method, Simpson rules, Romberg integration, all of it can be just in like one document, so it's way better. And then you can also save it as computational methods, right? And then you can have multiple methods in this one, and that's it. And then also there is this is the GitHub repository. It has many other such methods for numerical computations. If you are working with approximations, integrals, or solving equations iteratively, this setup makes your Ti-nspire a much more powerful tool. And then also more updates and methods will be added to this repo over time, so be sure to explore them if you are studying numerical methods or engineering math or anything related to that. and let me know if you need to have any other method in this repo as well.